Lots of problems in physics ask you to think conceptually about what's going on and then use your understanding to solve mathematically. For example, you might be asked, what's the effect of changing one variable on another variable? For example, maybe you're studying Newton's second law and you know that acceleration and force are related. You might be asked, how does doubling or tripling the force affect the acceleration? That's not an easy problem, but it can be even harder than that. You'll often see problems that ask you to change two variables at once and see how that affects a third thing. Newton's second law is a classic example of that. You might be asked, how does changing the force and the mass affect the acceleration? So we're going to look at a problem that does exactly that, that changes two variables at once and looks at what the final answer is for my third thing. Let me read this problem to you and then we'll get into the specifics. This problem says, a certain force causes an object to accelerate at 12 meters per second per second. If the mass is decreased by a factor of 3 and the force is increased by a factor of 4, what new acceleration will the object experience? So clearly we're changing both the force and the mass. You can see we're having less mass, 3 times less mass, and we're having more force, 4 times more force. And when you want to know what do both of those things together do to the acceleration. So the first thing I'm going to look at is how are force and mass related to acceleration? So that's an easy one. I know that one. That's Newton's second law. I'm going to write that down. Acceleration is force over mass. Force is in the numerator, mass is in the denominator. That means more force makes more acceleration. And more mass that's being pushed on is equivalent to less acceleration. Now what I want to say is, how do these changes in this problem affect the final answer? So let's start with the first change it mentioned. The first change it mentions is that the mass is decreased by a factor of 3. We're getting 3 times less mass. So logically you might just be thinking, okay, if it's less mass that's being pushed on, it's probably accelerating more. And you're right about that. We're just going to look at how much more is it accelerating. So let's see, there's 3 times less mass. That means my denominator is 3 times smaller. My denominator is less by a factor of 3 times smaller. So when I have a 3 times smaller denominator, that's going to make my answer go up 3 times. So the effect of the first change, of changing the mass, is to make the acceleration 3 times bigger. Now let's look at the other change mentioned in this problem. The other change is that it says the force is getting bigger by a factor of 4 times more push on this object. If there's 4 times more push, you might be thinking, oh, that's also going to make the acceleration go up. And you're correct about that as well. 4 times more force. That means my numerator is 4 times bigger, which is going to cause my answer to be 4 times bigger as well. So this first change, changing the mass, made the acceleration go up. Decreasing the mass by a factor of 3 made the acceleration increase by a factor of 3. This next change, increasing the force by a factor of 4, made my acceleration increase by a factor of 4. Now all I have to do is look at the number I started with for acceleration and apply those changes. Apply 3 times bigger and 4 times bigger. The number I started with in this case was 12. So I started with an acceleration of 12. And the first change, the mass change, made that go up times 3. And the next change, the force change, made that go up times 4. So all I have to do is apply both those changes. I have to start with my acceleration, my original acceleration, which was 12. And remember, decreasing the mass by a factor of 3 made this number go up by a factor of 3. And then increasing the force by a factor of 4 made this number go up by a factor of 4. So when all is said and done, the result of both those changes is that my new acceleration will be 12 times 3 times 4, 144 meters per second. That's increased both because we decreased the mass that we're pushing on and because we increased the force. Oops, one mistake. We're looking at acceleration, not meters per second. So bad, so bad. Meters per second. Per second. I feel better now.